Alrighty, today we're looking at geometric series. Our objectives are to find the sum of a geometric series, to apply the formulas for the sum of a geometric sequence to be able to solve problems, to determine whether an infinite geometric series converges, and then find its sum if it does, and lastly, to apply the formula for the future value of an annuity. So let's get started. A geometric series, it's much like an arithmetic series, but you're adding all the terms of a geometric sequence. The formula for a geometric series, after you add in number of terms with a common ratio of r, would look like S sub n, where n is the total number you're adding, equals a1, that's your first term, times 1 minus r, your rate, to the nth power, and that's all divided by 1 minus your rate. Now, it could also be written like this if you know a sub n, the value of your last term. So you have two options, and you'll use them just depending on what information is given. So let's practice this. We're going to find the sum of the first 10 terms of this sequence to the nearest hundredth, and our sequence is 5, then 15 over 2, 45 over 4, and continuing. The first step to be able to give that sum is to identify the key characteristics. The first being that we know a1 is 5. Another value that we need to know is our rate, which is going to be the quotient of those two values, the second over the first. Now, to be able to actually find that quotient, I would want to multiply by 1 over 5, since we have lots of fractions going on. And that simplifies to 3 halves, or 1.5 for your common ratio. Also, we know we're going to the nth position. Now that we know these, we can substitute them into the formula. We'll want to use the first formula because our last term's value is not known. So the sum of the 10 terms is going to be 5, which is a1, and then in parentheses 1 minus your rate, 1.5, that's the same thing as 3 halves, to the 10th position, all over 1 minus your rate. Go ahead and plug that into your calculator right now. Take a moment to do so. You should have found it to be, when rounded, 566.65 as the sum. All right, here's another example, a little bit different. We don't know our first term, and we're trying to actually find the third. To work with problems like this, we need to find our first term. That's required for these sums. So what we'll do is we'll plug in what we know and try and find a1. We know that the sum of those 6 is 189, the rate is 2, and our n value is 6. So plugging those in, 1 minus 2 to the 6th power is a negative 63. When you divide by that denominator, it's going to make that positive because 1 minus 2 is just going to be a negative 1. Then when you divide each side, you find that a1 is 3. Now we can use this value, plugging it into the explicit formula, to find the third position's value. So that looks like the first term's value, the rate, and then n. Our n is 3 minus 1. That will give us 12. There you have it. So kind of using some old formulas along with our new one. I really like this example. It's going to show us the power of geometric series and how they just grow so quickly. So let's say that you are in the position to be a caddy for a golfer, and he gives you the following choice for payments. You can have $1 for the first hole, $2 for the second hole, so on and so forth, and then he'll pay you $18 on the 18th hole. Or the other payment option is he'll pay you 1 cent, just one, for the first hole, and then he'll double it for every hole that you help him with thereafter. That would be 2 cents on the second hole, doubling, that would be 4 cents on the third hole, continuing up to the 18th hole. So which one would we choose? We have to look at these two separately. The first is just increasing by $1 each time, which means it's an arithmetic series, and we'll use that formula that we've seen. We'll plug in 18 for the in. The first payment is $1 and the final payment is 18. Using your calculator, you find that to be $171. Now the second one is a geometric series because it's doubling. So your rate is 2. We're going to plug that into the new formula that we're working with. So A1 is just 1 cent, that's 0.01. Our rate is 2 and we're going up to the 18th position. And take a moment right now to plug that into your calculator so that you can see for yourself that value. You should have found it to be $2,621.43. And I think at this point you would want to select the second payment option. That is the power of geometric series. You'll maybe remember how exponential graphs work. Well, this is an exponential model, so every small increment grows a tremendous amount. It's not just a linear increase, it is exponentially increasing. That's the power of a geometric series. So that's it for part 1. Stay tuned for part 2.